Hey everyone, today we are going to solve another Leetcode problem. It's called flood fill. So it's relatively an easy one. So if we look over here, we see this question has been asked almost all the major companies, including Facebook, Google, Adobe, Nvidia, Microsoft, and many more. Therefore, mastering this question is essential. So if you are ready, let's dive into some late coding and solve this question together. So here is how this question actually goes. We can see that we'll be given this m into n grid, and we are also given few variables here, SR, SC, which actually represents the initial position of this grid, and a color with which we have to actually fill this entire grid. And once we are done these manipulations, we actually have to return this image or grid, right? So let's go through this example, for example this, and then we try to figure out how we can actually solve this one. So as we can see that we are given this initial position, SR is 1 and SC is 1, so this represents this position, and from here what we have to do is we have to go all the 4 directions, right? We are allowed to go these 4 directions, so this is important. And then we have to update this with this 2, right? So this is what we have to do. So we have to convert it to 2. From here we are allowed to go into 4 directions, right? These 4 directions we are allowed to go, but we'll not be able to make any changes over here because these 2, 1 and 0 is different values, right? So we are only allowed to change values as long it matches with the neighbors. So in this case 1 is the initial value, this matches over here, so we are allowed to make changes over here, so this becomes 2. From here we again can go in 4 directions, so we can go over here, here, over here, and over here, right? So we'll make changes over here, so this becomes 2, this becomes 2. From here we can go over here, so this becomes 2, and so on, right? So in the end we'll see that we'll have this 2 2 2, so 2 2 2, and then we get 2 2 0 2 0 1, so 2 0 1. Now one question that you might have is that why we are not able to modify this bottom right value, right? Because it is also matches with the initial value 1, right? The reason for which we are not allowed to make changes over here because we are not allowed to go on the diagonal movement, right? The question clearly says we are only can go in 4 directions, which is up, down, and left, right. So this is one reason. So how we can solve this? So what we can do is we'll probably begin by filling the cells starting from this initial position, right? From this position, and then we'll check the neighbor cells in all 4 directions to see if their color matches with the initial color. So that means when we start from these positions, we also have to keep track of the initial value, right? Because when we go from one step to another, we again have to backtrack and have to see if that matches with this color. So this is one thing. And other than, I think it's a very simple problem that we can do. Okay, so I think this problem can be solved in both BFS and DFS approach, but in this video I'll be showing the DFS code. So let me know if you want me to show the BFS code as well. So to start with, what we have to do is to keep track of the color that was in the beginning, right? So what we can do is something like this. So this will actually keep track of the initial color, and this color we want to pass in the DFS shell that we're talking about, right? Okay, also let me change this variable name for better clarity. Okay, and in the int what we really like to do is to return this image, right? Assuming that this DFS will be able to handle all the cases, right? So, okay. So let me now write this DFS shell. So this will be a void method, right? Because in the end, we don't want to return anything. We just want to manipulate everything. And since we are passing it as a reference, so I think the void actually makes sense. And let me copy all these parameters over here. So, okay. Yeah, I think we have write everything over here. Now what we have to do is to write the main logic, right? So inside this DFS method, we actually have to update the current color with the new color, right? So we have to update the current color. How can we do this? We can do this like, okay. And then once we update this new color, then we also want to go in the 4 directions, right? So we can recursively call this DFS method. So we can say something like this. Okay. Now let's say, now let's assume that we are standing over here, okay, in these positions. From here, we can go in 4 directions, right? So let's say we want to go on my right, so on that case what we can do is we can say, okay, then let's just add just one so that we can go in the next row, next column, right? Similarly, we can simply remove one. So I think this is what I mean. So from here and here, right? Same way we can also manipulate the column to go in these 2 directions, right? Okay. Now since this is a recursive method, as you can see, we also have to put some base conditions as well. But that's not the only case, because if we don't pay any base condition, there is a high possibility that we will definitely go out, will definitely encounter some issues, right? For example, let's say if we are already sitting over here or standing over here, and if we want to go on its left or go on the top, it will go out of bound, right? So we don't want to go on that route. So to solve those issues, what we can do is we can write some base condition, something like this. So if s is less than 0, right, or AC is less than 0, on that case we simply want to return, right? So we'll have few more conditions that we need to fill over here. For example, if it already, for example, let's say when we are already sitting over here, standing over here, that time we don't want you to go in this side, right? To stop or to prevent that thing from happening, what we can do something like this. And also we have to do the same logic for S row, right? So for example, whenever we are standing over here, we don't want you to go over here, so this is why we put these conditions here. Now there is one more things we have to keep in mind, and if you pay attention over here, that image is starting from the pixel, so this is the initial positions from where we have to start filling everything, right? And you should perform a flat fill on the images starting from these positions, okay? And here is the thing, starting pixels of the same color, right? So I think we haven't written that code, so let's quickly write that logic as well. So if the current color, right, doesn't match with the old color or the initial color, right, on that case we don't want to do anything, we simply want to return. I think this is pretty much everything, right? This actually solves everything. But before actually submitting this code, um, let me ask you one thing. What do you think? What will happen if the starting color actually matches with the new color, right? For example, what I mean is, let's say I have given you this grid, right? And then I'm saying, okay, you have to start from this position, and what I want you to update is with the value 2, right? So you see that then there is no meaning of updating anything because it's already matches, right? So on that case we don't want to make any changes, so we can simply write that code over here. So if the position already matches with this new color, then we simply want to return the image, right? Okay, I think we are done here, so let me submit the code. Okay, so it got accepted. So the time complexity for this given problem is order of m into n, where, okay, so m cross n, right, where m and n is the dimensions of the grid. So it is, so in the worst case it needs to fill the whole grid, right? So on that case this will become order of m into n. So that is one thing. And I think, and the time complexity also depends on this recursive call as well, and in the worst case we probably have to go all the way down, right? So that, for that we can say space complexity will be order of n, where n actually talks about or considers the stack we are considering. Okay, so yeah, so that's it for today. So let me know if you guys have any question, comment below, and I'll see you in the next video.